Hi, welcome to this series of videos on the GMAT quantitative reasoning section. The quantitative reasoning section of the GMAT exam has two types of questions. One is the problem solving and the other is data sufficiency. Problem solving is your basic question with 5 answer options and you have to select the one which suits the best. And data sufficiency, you will have one question and 2 statements, of which you will have to check whether the given information in these statements is enough to answer the question or not. So, today we will be looking at some data sufficiency questions on the topic of inequalities. So, these are your basic answer options for every data sufficiency type of question. Option A is statement 1 alone is sufficient, but statement 2 alone is not sufficient. And the option B is statement 2 alone is sufficient, but statement 1 alone is not sufficient to answer the question. Option C is when both statements together are sufficient, but neither statement alone is sufficient. And when answer option D is when each statement alone is sufficient to answer the question, and answer option E is statements 1 and 2 together are not sufficient. Let's look at the first question now. If x and y are integers, is x greater than y? First statement is x plus y is greater than 0 and second statement is y to the power of x is less than 0. Okay, the question is asking us, is x greater than y? So, let us look at the statement 1 that is given. You have x plus y is greater than 0. So, you know that the sum is positive, and because the sum is positive, either both can be positive or one can be negative and one can be positive. So, you do not know which one is positive, which one is negative, and if both are positive. So, we do not know, we cannot comment whether x is greater than y or x is less than y or equal to y. So, this statement is therefore not sufficient to answer the question. Let us look at statement 2. It says that y to the power of x is less than 0. So, what does this tell us? That y is negative. Only a negative number raised to some number can be positive. Positive number raised to any number, be it positive, negative or 0, can never result in a negative number. Therefore, if y to the power of x is less than 0, y should definitely be negative. So, we know this, but we do not know anything about what x is. X can be positive or x can be negative. Either, or it can be it cannot be 0, it can be positive or negative. So, therefore, this alone is not sufficient to answer the question. They are saying that x and y are integers, but no, we do not know which one, what x is in the statement 2. When we look at both statements together, that is statement 1 and statement 2 together, you have x plus y is greater than 0 and you have y to the power of x is less than 0. From here, you know that y is definitely negative, okay. But from here, since we know that the sum should be positive, that therefore x will have to be positive. A positive number plus a negative number can give you a positive number. If x is negative, then the sum will be negative. Therefore, we can definitely say that x, which is a positive number will always be greater than y, which is a negative number. Therefore, the answer is option C, where both together are sufficient to both together is sufficient to answer the question. So, answer is option C. Let us move to the next question now. Is x square greater than x? They are asking us, is x square greater than x? Statement 1 is telling us x square is greater than 1. Okay. So, when x square is greater than 1, either x is greater than 1 or x is less than minus 1. Because x square is greater than 1 means that x square minus 1 is greater than 0. Therefore, x plus 1 into x minus 1 is greater than 0. By solving this, you will get that x is either greater than 1 or x is less than minus 1. Okay. So, in this, can you tell for sure whether x square is greater than x? For x square to be greater than x square minus x is greater than 0. So, x into x minus 1 will be greater than 0. either both are positive or both are negative. So if both are positive, then you have x is greater than 1, or when both are negative, you have x is less than 0. So this is what you have to be able to say, is x is greater than 1 or x less than 0. Here it is saying that x is greater than 1 or x will be less than minus 1. So it will definitely be less than 0. It cannot be greater than 0. Therefore, the statement here is sufficient to answer the question. And the second statement is telling us that x is greater than minus 1. So here, when x is greater than minus 1, it can also come in the range where x is, if x is equals to say minus 0.5, then it belongs in this interval. Let's look at the number line here. X is 0, 1. Either x should be less than 0 or x should be greater than 1. So if x is minus 0.5, it will lie in this region, but if x is plus 0.5, it will not lie. So therefore there is ambiguity. The answer, therefore this is not sufficient to answer the question. Whereas option 1, in statement 1, we had seen that x is either less than minus 1 or greater than 1. So when it is in these areas, it is definitely satisfying your required condition. So therefore the answer is answer option A, when statement 1 alone is sufficient but statement 2 alone is not sufficient to answer the question. Let's look at the next question now. Is x greater than y? The question is asking, is x greater than y? Statement 1 is telling us that x plus y is equal to 10. So we don't know what x and y are. X and y can be 2 and 8, 3 and 7, 5 and 5. They can be equal or they can be, either can be greater. We cannot comment on which one is greater by the given sum that is greater than, that's equal to 10. Therefore, this is not sufficient information. Statement 2 is telling us x and y are prime numbers. So they can be set of any two prime numbers. They can be 2 and 3, they can be 3 and 5, they can be 7 and 11, they can be a set of any prime numbers. So therefore, this is also not sufficient to tell us which is greater. And when you combine both statement 1 and statement 2, you know that x plus y is equals to 10 and they are both prime numbers. Therefore, you can say that either 3 plus 7 is equals to 10 or 7 plus 3 is equals to 10. X can be greater or lesser than, or it can be equal. They did not even say that they are different numbers. They can be equal. They can both be 5 as well if they are prime numbers. Therefore, you cannot comment whether x is greater than or less than or equal to y. Therefore, not sufficient. So the answer comes out to be option E, when both the statements together are also not sufficient to answer the question. Let's look at the next question. X, y and z are positive integers. Is x minus y into y minus z into x minus z, is it greater than 0? Okay, let's look at what the first statement says. First statement says that x square plus yz is equals to xy plus xz. That means that taking all of the elements onto one side, xy and xz, let's say x square plus yz minus xy minus xz is equals to 0. Taking x common from here, you have x into x minus y, plus taking z common here, you will have z into y minus x is equals to 0. If you take x minus y out common, you will have x minus z. Y minus x is minus 1 into x minus y. So x minus z is equals to 0. So when you know that the product of these two numbers is 0, then definitely you know that x minus y into y minus z into x minus z will be equal to 0 also, because 0 into anything, y minus z can be anything, it will give you a product of 0. Therefore, you can definitely say that it is not greater than 0. Therefore, this information is sufficient to answer the question that is asked. Similarly, when you look at statement 2, you have xy minus y square is equals to xz minus yz. Taking them on one side, you have xy minus y square minus xz plus yz is equals to 0. Taking y common here, y into x minus y, and taking minus z common here, minus z into x minus y is equals to 0. Therefore, x minus y into y minus z is equals to 0. Again, you know that this means that x minus y into y minus z, which is this, into x minus z will be equal to 0, because this product is equal to 0. So, this into anything x minus z can be anything, and it will always be equal to 0. Therefore, this is also sufficient to answer the question. Therefore, the answer comes out as answer option D, when each alone is sufficient to answer the question. Let's move to the next question now. If y is less than x is less than z and x, y, z is less than 0, is x, y greater than 0? Y is less than x is less than z and x, y, z is less than 0. When is this possible? When all three of them are negative, that is either all x, y, z all are negative. Negative into negative will give you positive, and then into another negative number will give you a negative number, or you have x, two of the numbers have to be positive, two numbers have to be positive and one should be negative. So, that will be the least number out of these three numbers. Y is the least number, therefore, y should be negative, the least number is negative, and the other two x, z should be positive, that is greater than 0. So, these are the two conditions, these are the two ways that this equation can be fulfilled, that x into y into z is less than 0. So, the question is asking us, is xy greater than 0? Okay, statement 1 is telling us that yz is greater than 0. So, either y is positive and z is positive, which is not possible. Here we have seen that either all are negative or y is negative and z is positive. So, this is not possible, and one has to be or else both are negative, that is y is negative and z is negative, which is possible. Then all are negative. All are negative, if that means that x is also negative. So, the product will be xy will be a positive value, of course. So, we can answer this question that yes, since x and y are both negative, the product will be greater than 0. Now, the second, so therefore, this is sufficient to answer the given question. Now, the second statement says that xz is greater than 0. So, it is possible when x is positive and z is positive. Yes, you can have x and z positive, then y will be negative. So, the product will be less than 0. Product xy will be less than 0, because y is negative and x is positive. Okay. Now, another option is when they are both negative, that is x is negative, z is negative, then again y will be negative. So, the product xy will be greater than 0, because both are negative. So, the product will be positive. Therefore, there is ambiguity, you cannot say for sure which one it is. Therefore, this information is not sufficient to answer the given question. The statement xz greater than 0 is not sufficient, because either xy can be less than 0 or it can be greater than 0. So, therefore, it is not sufficient. Therefore, answer is option A, when statement 1 alone is sufficient to answer the question, but statement 2 alone is not sufficient to answer the question. Let us look at the next question now. Number x, y, z is the product of a positive integer n and 9 is x plus y plus z equal to 9. Okay. They are saying that this x, y, z is equals to some product of some number n in 9. So, when is a number a multiple of 9? When its sum of its digits is equals to a multiple of 9. So, x plus y plus z will have to be a multiple of 9. It can either be 9, it can be 18 or it can be 27. 27 is possible when all three digits are 9. So, 9 plus 9 plus 9 will be equal to 27. but it cannot be more than that, that is the maximum value. So, hence it is one of these 3 values which will make xyz a multiple of 9. Now, let us look at the information given. So, first piece of information tells us that x plus y plus z is less than 15. Okay. In less than 15, you only have one option, that is 9. So, therefore, x plus y plus z is equals to 9. So, therefore, we can this information is sufficient to answer the question that yes, the sum is equals to 9. In statement 2, if you look at it, x plus y plus z is greater than 8. So, if it is greater than 8, it can either be 9 or it can be 18 or it can be 27, it can be any of these 3. Therefore, it is not sufficient to answer this given question. Therefore, the answer option is option A. Answer option A. Since statement 1 alone is sufficient to answer the question, but statement 2 alone is not sufficient to answer the question. Let us move to the next question now. Is x closer to 30 than to 60? Okay, the first statement tells us that 38 minus x is greater than x minus 32. 38 plus 32 is greater than 2x, which means that 2x is less than 38 plus 32 is 70. So, x is less than 35. When it is less than 35 on the number line, obviously it is much closer to 30 than to 60. Therefore, we can say yes, x is closer to 30 than 60. Therefore, this information is sufficient to answer the question. Let us look at statement 2. Statement 2 says mod of x minus 45 is less than 15, and we know that whenever mod of a is less than b, that means that a lies between b and minus b. So, therefore, x minus 45 will be between 15 and minus 15. Adding 45 to all throughout this inequality, you have minus 15 plus 45 is less than x less than 15 plus 45. X minus 45 plus 45 will be leave you with x. Okay. So, here you have 30 is less than x is less than 40, 50, 60. So, x is lying between 30 and 60. But you cannot definitely say whether it is closer to 30 or whether it is closer to 60. It can be either of the two. Therefore, this is not sufficient to answer the question. Therefore, answer is answer option A, and statement 1 alone is sufficient to answer the question, but statement 2 alone is not sufficient to answer the question. Let us move to the next question now. If x is a negative integer, is x less than minus 3? Okay, the question is asking us whether x is less than minus 3. Statement 1 is telling us that x square plus 6x is less than 7. Taking 7 to the other side, you have x square plus 6x minus 7 is less than 0. So, this is x square plus 7x minus x minus 7 is less than 0. So, x plus 7 into x minus 1 is less than 0. Either both are negative. When they are both, no, one should be positive, one should be negative. So, x is greater than minus 7. So, x plus 7 will be greater than 0 and x is less than 1. X minus 1 will be less than 0. So, x is between 1 and minus 7. But so x is between 1 and minus 7. Can you say that it is less than minus 3? It can be less than minus 3 and it can be greater than minus 3 also. So, therefore, this equation is not sufficient to answer the question. Let us look at the second statement. You have x square plus mod x is less than equal to 2. So, since x is a negative number, so a mod of x is equals to minus x. So, x square minus x is less than equal to 2. Taking 2 to the other side, you have x square minus x minus 2 is less than equal to 0. So, x square minus 2x plus x minus 2 is less than equal to 0. X minus 2 into x plus 1 is less than equal to 0. Again, so it's less than equal to 0, that is it's a negative number, only possible when x is greater than equal to minus 1 and x is less than equal to 2. The only negative number that is possible for this is, that means that x is equals to minus 1, because x is a negative integer. That is the only negative integer that's satisfying this condition. Therefore, and thus this means that yes, x is not less than minus 3, it is greater than minus 3, it's equal to minus 1, but this information is sufficient to answer the question asked. Therefore, answer is option B, where statement 1 alone is not sufficient, but statement 2 alone is sufficient to answer the question. Those were some sample questions on the topic of inequalities for the data sufficiency type of questions. Hope they were clear. Thanks for watching.